In this video, we'll walk through designing the connections or channels between the nodes of our skill tree. These connections will act as a visual representation showing which nodes connect to which other nodes. Firstly, we need them to be highly visually customizable, just like the nodes. We don't want connections that only look one way, but then have highly visually customizable nodes. We want connections that can match or accentuate the nodes to really take the visuals of our skill tree to the next level. Lastly, we want to have a visual option for a particle-like effect. So we'll be walking through a way to design a particle-like effect in a material without having to use any particles at all. Much like the nodes, everything for the design will be done in the material for maximum optimization and ease of use. So in our content browser, we'll open up the Skilltree Pro folder, go down to widgets, and don't worry if you don't have this details widget yet. I filmed these in a different order. We're gonna make our connector widget. For every connection in the graph, there's going to be a very simple widget with a material. So we'll right click, get onto user interface, widget blueprint, user widget, and we'll call it WBP Skilltree Connector. Open it up, and this is about as simple as it could possibly be. It's just going to be one image. So we'll open up common, drag down an image, and we're going to change a couple things. Under the image size, we'll make it 10 by 200. And just so we can see the change visually, we'll go here to desired and we'll draw as box. And because this is just a visual element that we'll never directly interact with, we're going to make it not hit testable, self and all children. So now that our basic connection design is done, we're going to add one to our skill tree every time we add a node so we can see the connections between the nodes. So we'll compile, go back into the content browser, open up our WBP skill tree widget, go into the graph, and we're going to search for the add node branching function. And we're going to add it here. So when we add a node, we'll add the connection as well. Let's just drag this over to include that. So let's add a pin, zoom in, and we're going to drag these two pins down. I'm just control left clicking, and we're going to add the connection before we add the node and after we calculate the node location for the second pin in the sequence. So first of all, we don't need to add a connection if it's the base node, if it's the first node in the graph that's getting added. So remember, we have these inputs, node and parent node, and we can get them right this way by right-clicking and going down to the bottom, get node, and get parent node. We could also just drag out this way. This just keeps it a little more tidy. And we want to say if they're not equal, B left-click, we can execute the following code. And what we're going to do here is just create the widget that we just made and then add it to the skill tree in the right orientation. So create widget, skill tree connector. And remember, we've already designed a way to artistically control the spread of our skill tree, or how far the nodes are from each other. So we want to input that into this widget so that we can control its length that way. We can adjust its length according to the spread that we implement in the component. So we'll go back up here to the skill tree connector widget and come over here to the graph and add in a couple of input variables. One will be the connector length, make it a float. The next will be the connector width, and we want to make both of these instance editable, expose on spawn. And we can compile, and now come back over to the skill tree widget and right click here, refresh nodes, and we can see our new inputs. And for now, we're going to hard set the variables because we just want to see what it looks like, get it working in our skill tree, but we'll come back to this later and have them customizable. Let's promote this to a local variable, call it connector. And we'll just get the player controller, put it in here. So now that we've created the node widget, we're just going to add it to the canvas. And to do so, we're going to reuse the function that we created earlier down here, add widget to nodes canvas. So you can just drag it in from here or copy paste from here. We're going to give ourselves some space to work with. The widget is going to be this connector local that we just created here. The Z order will be 2. Because we want them to be behind the nodes, which has a Z order of 3. The alignment will be 0.5, 1, and the pivot will also be 0.5, 1. And we're going to calculate the position and angle. So get parent node location, And for the angle, we're going to get the node location, and we can copy paste this, and the parent node location, subtract, and 2 vector. We want to convert this 2D vector into a 3D vector so we can use this function here, rotation from X vector. Right click, split, and from the yaw, we'll add 90. Plug that into the angle, and we can comment it. And we'll comment this whole thing. Add connector. And I just caught one mistake here. We have to change this. We can delete the parent node. Does not equal the base node. And now if we fire up our game, we'll see that every node is now spawning a connector, which is pointing to the next node. However, we'll notice that they're off center because they're all starting exactly where the parent node is. So to fix that, rather than hard setting this value connector length at 200, we'll get the node location and the parent node location, get the distance 2D between the two, and plug that in. In the connector widget, we need to make those variables mean something. So we'll come over to the connector widget, the graph, and on construct, come back to the designer, make the image a variable, compile, drag that image in, set brush, split, and we want to get brush, split here, and we want to split the in-brush image size. And in the X, we want to add connector width, and in the Y, we want to add connector length. And we want to put everything else back in the way it was before. Compile. Now when we fire it up, we see they reach all the way from the parent node to the next node. So that's one problem solved. So now the next issue is when we're fading in and out the skill tree, we can see the connections behind the nodes, and it kind of looks like raw ass. So what we want to do is we want to find a way to trim the ends of the connection, snippety snip snip, to come right up to the end of the node. So in the skill tree widget, we'll make a couple new variables under node generation category. So we can just duplicate the edge buffer because it's already in that category. And we'll make a variable called connector end trimming, duplicate it. Another variable called connector thickness, both floats. Now we're going to take this input into the connector length, take that end trimming, multiply it by 2, because we're going to trim each end, and we're going to subtract that from what was already the length. And we can just drag the thickness in and put it directly into the connector width. And over here, we also need to modify the position input. So we want to take the parent node location and add it. Make sure you connect this. We can copy and paste this down here. And we'll say the node location local minus the parent node location. We'll normalize 2D and multiply it by the connector end trimming. Plug that in. Now if we come over to connector thickness and set it to 10, and connector end trimming and set it to 63, after compiling, you can set them. We fire up our game, and we notice that the connectors go exactly to the ends of our nodes. Now remember, we're adding all the controls to the component so that we can have them all in one centralized place. So we'll do that now. Come back over to the content browser, open up the interface, iSkillTreePC component. So we'll click on tree info and add 2 more outputs. Call them connector width and connector ends trimming. Make them floats. Compile, close that, and we'll go to the components, open up the base, right click and refresh node, and you'll see the new inputs here. And we can promote these to variables, connector width, right click, promote connector ends trimming, and we can put these into categories. We'll call it skill tree, vertical line, connector appearance. I'll drag this into the same category, and we'll compile, make the connector width 10, and the connector ends trimming 63. And now, just as a reminder, in our child component, in that connector appearance category, we see them and we can change them and set them to whatever we want and play with them at a later time as we have different versions of skill trees. So we'll close our components. And the last thing we need to do is in the WBP skill tree, in that function catch skill tree and component and info, we need to set these variables to the ones that we created. So the connector width is the connector thickness. We just named it differently. And the ends trimming is the ends trimming. And we can comment this. So now our connections between the nodes are procedurally generating with the nodes as we create them in our skill tree, and they're the correct position, orientation, and length. Now we want to customize the way that they look. So in the content browser, we'll come to the materials folder, right click, make a material, call it M node connector. Open it up. In the material domain, we'll make it user interface, blend mode translucent, and just set the base color to white, alpha for now, save. And before we forget, go to our connector, the designer, open up the brush, and add this new material here. And that's everything, all the work we're going to do in the connector and skill tree, so we can close those. And the rest of the work we're going to be doing in this video is all in the material. So we'll start in the material by doing our favorite thing in the world, which is to create an SDF box. If you're just joining this video and you didn't see the earlier tutorials, these material functions are from the UI Material Lab, which is downloadable on the Epic Games Marketplace. Let's start inputting some of these. One, left click, right click on it, convert to parameter. We'll call this unlearned width. Eventually we'll have learned and unlearned parameters in this material. We'll just do unlearned for now. And that's the base appearance of the connector. And we'll make it 0.1. Append vector, one left click, make this 1. So 0.1 and 1. Plug it into size, one left click, convert to parameter, unlearned glow, and we'll make this 0.08, M left click to multiply it by -1, and this is glow min, and glow max you can drag from the 0.08 into here, and we'll one left click again, right click, convert to parameter, call this unlearned corner radiuses, and we'll make it 0.4, plug it into corner radiuses. And in the fill output here, we'll saturate. And again, this clamps between 0 and 1. And we'll do a named reroute, and we'll call it unlearned connection. And we'll comment this. And over here in the outputs, we'll get that unlearned connection. M left click to multiply. Promote B to a parameter. We'll call it unlearned opacity. And we'll set its default to 1. Saturate, plug it into opacity, and now we can see something that looks a bit nicer for a connection between nodes. Now one thing worth noting is we have a lot of empty space here in this widget, and that's so we can do a lot of cool kind of particle effects that are dissipating off around it if we so choose. So because there's empty space, it's going to be a lot smaller. So we want to compensate for that in the component. We'll go over to the component, the base component, this variable here, connector width, and we have it set as 10. We'll up it to something much larger, like 300, compile, and also make sure you save and apply the material. And if you open it up, you can see we have that new appearance that's starting to take shape with the connections. Now let's add the ability to change the color. So we'll do 3 left click, convert to parameter, we'll call it unlearned tint, and set that default to white, plug it into the final color, save, which also applies in our project settings. Now we can play around with the color. That works. Now, like we mentioned at the beginning of the video, we want this to have the ability to look kind of like a particle effect or like mist that's, surrounding that channel. So we're going to spend the rest of this video making it look cool, giving us the ability to have parameters to make it look like a static line or like some kind of a mist or different ways. So to create this mist, we're going to start with a tiling noise texture. If we come over here to the content browser, go into Engine Content, click on the folder, and type tiling noise, we can see there's this tiling noise 05 texture. We're going to Control D to duplicate it, drag the duplicated one into our materials folder, not the engine content one. Be very careful not to alter engine content ever. Open up our materials folder. You can just call it tiling noise. Come back to the connector material, right click, texture sample, and if it didn't automatically show up as tiling noise, then choose it down here, our tiling noise texture. And the technique we're going to use is move this texture, pan this texture as an overlay over this, and fade it out at the edges, and have two of these textures panning at the same time to give it kind of a fluctuating look. So from the UVs, we'll input a panner. For the coordinates, we want to get a text chord, and we want to multiply that. One left click, convert to parameter, something called mist repetition. And we want to make a named reroute here, call it particles repetition. Input that into the multiply. Set the mist repetition to something like 0.3. And we can make a note here. And we want to make a named reroute for this as well. Call it mist chords. And inside the coordinate of the panner, we can plug in that mist chords. And inside the time, we can get time. And for the speed, we want to one left click, convert to parameter, mist speed. And we can set it as a default of 0.15, M left click to multiply. And we can take that particles repetition named reroute that we created, and we can make another named reroute, call it mist speed, and comment this. And over here we can get that named reroute, set this to 1 on the X, 1 on the Y, multiply this. This doesn't actually change anything up here, but you'll see why we're doing this in a moment. And we'll plug this multiply into speed. And now we're gonna select everything except for time, control, duplicate it down here. And the only difference on the bottom one is the X, we're gonna make 0, and the Y is still 1. We're gonna plug time into here as well. M left click, multiply these two, and now we have an overlay of two noise textures going. So we're gonna make a named reroute, call this panning noise unmapped. And now we can comment this, make panning noise texture. And now over here, we're gonna take that connection and do a max between it and this, the panning noise unmapped. And now we can see, we apply, we can see we have this kind of fluctuating noise going on behind the connector. So one problem we can see immediately is that once it gets to the edge, it clips. And so if we open it up, we could see it. It clips at the edge, which looks really bad. So we'll implement a solution for that here. We're gonna make it so the closer it is to the center, the more visible the mist is. And as you go out, it just decreases in visibility. And we also wanna make that controllable with parameters. So we'll put in a text chord, and we'll do a component mask, deselect G so it's just R. So in other words, this is just the X coordinate of the text chord. In other words, we're just controlling it going this way. We want it to be even going along the Y. We'll do a min, and down here a 1 minus, M left click, multiply by 2, and we're gonna remap value range into this input. Now here we can create a parameter, 1 left click, convert to parameter, mist width variation. We'll set its default to 0.6, and we'll do a 1 minus, put it in the input low, and put a constant of 1 into the input high. Make 2 more constants, put 0 into the target low, and change this one to 1, and put it into the target high. And we're gonna do a power coming off of here, and promote the exponent to a parameter, call it mist side fall off. And we'll set its default value to a 3. And we can make a named reroute for this, call it mist side fall off. And what this does is creates a smooth gradient on the sides of the mist. And now down here, we can simply multiply these two. Panning noise unmapped, multiply, mist side fall off. We'll create a named reroute and we'll just call this mist. This is our final mist. And now up here, we can get rid of the panning noise unmapped and just plug in mist. And now we're seeing something where it's kind of dissipating as we go out. However, there are still a couple things we want to improve. Number one, we can still see the clipping at the tops and bottoms. And number two, we want an ability to control the intensity and the intensity power to really have a lot of control over how much the mist goes out and how powerful it is at different points of it going out. So let's start with controls over the appearance of the mist and the power of it. Make a little space over here. And we want to take this panning noise unmapped and remap it. Remap value range. And the input low can simply be 0. And we're going to one left click, convert to parameter, make a new parameter, call it mist strength. We'll set its default to 0.9. And we'll make a named reroute, call it mist strength. And we'll do a 1 minus. Plug that into the input high. The target low can also be 0. And in the target high, we'll do an if. Mist strength will be A. And we'll make two more parameters here, 0, and then the bottom one will be 1. Everything will be 0 except for A is greater than B, which will be 1. We want to do a named reroute and just call this panning noise. And we can comment this. So now we've turned this panning noise unmapped into this panning noise. And we want to use the panning noise down here instead. Now we can see something that looks a little bit nicer. Now we also want to create a smooth gradient on the upper and lower ends of the mist so it doesn't clip there. And we'll put that functionality over here. We're going to use a smooth step to accomplish that. One left click, input this into smooth step, into the min, and into the max. We're going to add and saturate so it doesn't go over 1. Put that into the max, and we're going to convert this, promote this to a parameter, call it ends fall off. And we'll set its default to 0.05. And we'll create another smooth step down here. And we'll keep the min at 0 and put this ends fall off directly into the max. And for the values of both, we'll get a text chord and we'll do a component mask. And this time we'll get the G value. So we'll deselect the R, and this is to get the Y element of it. And we'll input the G into the value here. And we'll do a 1 minus into the value down here, and we will multiply both of these and do a named reroute and call it ends gradient. And essentially what we're doing here is smoothing out both the top and the bottom and then multiplying those together so that they're both smoothed out. If we preview this, you can see that the top and bottom are smoothed out here. So now we've created this ends gradient. We'll come down here and we'll take this mist side fall off and we'll multiply it by that new ends gradient that we just created. And we'll do a named reroute over here and call this mist opacity. So this is the overall mist opacity. We're masking out the left and right side from this and the top and bottom from this. And so over here, our final mist wants to be the panning noise multiplied by that mist opacity. And now we've inserted this functionality so it kind of fades out on the ends. It's starting to look better. Now if we fire up the game, we can see we have these connections with this interesting kind of energy particle-like effect that's going on with them. We can comment this a bit more. This whole chunk just fades out misted edges. And this whole chunk just creates a mist. And now a good thing to do would be to create a child material instance of this so we can finally play with these parameters. So we'll apply and save, browse to this in the content browser here, right click it, create material instance, and let's assign this instance to the widget. And we'll open the material instance. And if you play with the parameters a bit, you can get something that you like a bit more. And if we open it up, we can see we have this kind of cool energy vortex thing going from parent to child nodes. And we can open up the component and take away the ends trimming. And we can see it just pouring all the way into the nodes now, which is kind of cool. So you may want ends trimming, you may not. It's just a design choice. Or maybe do it part way. And we can also go into the material for the node, the instance, and you can find something you like. Maybe set the highlight tint to a color that matches the unlearned tint of the connector, and then you fire up the game, and you see something that looks pretty fucking beautiful, pretty genuinely awesome. And remember, every element of this is completely customizable because of the way we've set it up. So you can play around with the parameters now on the two material instances, the node instance and the connection instance, and find something that probably looks even cooler than this. So now that we have the skill tree looking the way that we want, in the next video, we'll create the ability to click on a node and see its details.